So welcome everyone to our session on next generation CI/CD with GKE and Tekton. So I'm Kim Lewandowski and I'm a product manager at Google.
And hey everybody, I'm Christie Wilson. I'm also from Google Cloud and I'm an engineering lead on Tekton.
So before we get started, a quick show of hands. How many of you are running Kubernetes workloads today? Wow, quite a few, awesome. And how many of you are practicing CI/CD? Okay, awesome. And then using Jenkins? Nice. Something else? Okay, cool, good mix. So today we're going to cover some basics. We're going to talk about a new project called Tekton that we've been working on. We're excited. We have two guest speakers joining us today to talk about their integrations with Tekton. We're going to briefly cover Tekton governance, and then finally, what's in the pipeline for us.
So we're here to talk to you about the next generation of CI/CD. And we think that the key to taking a huge leap forward with CI/CD is cloud-native technology. So I, for one, found myself using this term cloud-native all the time, but I realized that I didn't actually know what it meant. So this is specifically what cloud-native means. Applications that are cloud-native are open source. Their architecture is microservices in containers, as opposed to monolithic apps on VMs. Those containers are dynamically orchestrated, and we optimize resource utilization and scale as needed. The key to all of this is containers. Containers have really changed the way that we distribute software. So instead of building system-specific binaries and then installing those and installing a web of dependencies, we can package up the binaries with all of their dependencies and configuration that they need and then distribute that. But what do you do if you have a lot of containers? That's where Kubernetes comes in. So Kubernetes is a platform for dynamically orchestrating containers. You can tell it how to run your container, what other services it needs, what storage it needs, and Kubernetes takes care of the rest. And then in addition to that, Kubernetes abstracts away the underlying hardware. So you get functionality like if a machine that's running your container goes down, it'll be automatically rescheduled to a machine that's up. And in Google Cloud, we have a hosted offering of Kubernetes called Google Kubernetes Engine, or GKE. So this is what cloud native ends up looking like for most of us. We use containers as our most basic building block, then we dynamically orchestrate those containers with Kubernetes and control our resource utilization. And these are the technologies that we're using to build cloud native CI/CD.
Cool. So for those not familiar with CI/CD, and it sounds like most of you are, it's really a set of practices to get your code built, tested, and deployed. So CI pipelines are usually kicked off after a pre-submit workflow and determine what code can be merged into a branch. And then there's CD, which is what code changes you then deploy to a branch either automatically or manually. And so what we've learned is that there's not really a one-size-fits-all solution. There are projects that just want something simple and just something that works out of the box. And then there are companies with really complex requirements and processes that they must follow as their code travels from source to production. So it's an exciting time for us in this new cloud-native world for CI/CD. So CI/CD systems are really going through a transformation. CI systems can now be centered around containers, and we can dynamically orchestrate those containers, and using serverless methodologies control our resource costs. And with well-defined conformant APIs, we can take advantage of that power and not be locked in. But in this new world, there's a lot of room for improvement. Problems that existed before are still true today. And some are just downright harder. If we break our services into microservices, they inherently consist of more pieces, have more dependencies, and can be difficult to manage. And the terminology is all over the place. The same words can mean different things depending on the tool. And there are a lot of tools. It seems like every week a new tool is announced. So I can't even keep up with all of them, and I know that our customers are having challenges making their own tooling decisions. So it's great to have this many choices, but it can often lead to fragmentation, confusion, and complexity. But when you squint at all these continuous delivery foundation or solutions, at their core, they all start to look the same. They have a concept of source code access, artifacts, build results, etc. But the end goal is always the same: get my code from source to production as quickly and securely as possible. So at Google, we took a step back, and after a few brainstorming sessions, we asked ourselves if we could do the same thing to CI/CD that Kubernetes did with containers. That is, could we collaborate with industry leaders in the open to define a common set of components and guidelines for CI/CD systems to build, test, and deploy code anywhere? And that is what the Tekton project is all about. Tekton is a shared set of open source cloud-native building blocks for CI/CD systems. Even though Tekton runs on Kubernetes, the goal is to target any platform, any language, and any framework, whether that's GKE, on-prem, multi-cloud, hybrid cloud, tribrid cloud, you name it. So Tekton started as a project within Knative. People got very excited to be able to build images on Kubernetes, but very quickly they wanted to do more. They wanted to run tests on those images, and they wanted to define more complex pipelines. And as enthusiasm grew, we decided to move it out and put it into its own GitHub org, and where it became Tekton. So again, the vision of this project is CI/CD building blocks that are composable, declarative, and reproducible. We want to make it super easy and fast to build custom extensible layers on top of these building blocks. So engineers can take an entire CI/CD pipeline and run it against their own infrastructure, or they can take pieces of that pipeline and run it in isolation. And the more vendors that support Tekton, the more choices users will have. And they'll be able to plug and play different pieces from multiple vendors with the same pipeline definition underneath. So Tekton is a collaborative effort, and we're already working on this project with companies including CloudBees, Red Hat, and IBM. And we've made a super big effort to make it easy for new contributors to join us. And again, pipelines is our first building block for Tekton, and now Christie will be diving deeper.
So Tekton Pipelines is all about cloud-native components for defining CI/CD pipelines. So I'm going to go into a bit of detail about how it works and how it's implemented. So the first thing to understand is that it's implemented using Kubernetes CRDs. So CRD stands for Custom Resource Definition, and it's a way of extending Kubernetes itself. So out of the box, Kubernetes comes with resources like pods, deployments, and services, but through CRDs, you can define your own resources, and then you create binaries called controllers that act on those resources. So what CRDs have we added for Tekton pipelines? Our most basic building block is something we call a step. So this is actually a Kubernetes container spec, which is an existing type. A container spec lets you specify an image and everything you need to run it, like what environment variables to use, what arguments, what volumes, etc. And the first new type we added is called a task. So a task lets you combine steps. You define a sequence of steps which run in sequential order on the same Kubernetes node. Our next new type is called a pipeline. A pipeline lets you combine tasks together. And you can define the order that these tasks run in. So that can be sequentially, it can be concurrently, or you can create complicated graphs. The tasks aren't guaranteed to execute on the same node, but through the pipeline, you can take the outputs from one task and you can pass them as inputs to the next task. So being able to define these more complex graphs will really speed up your pipelines. So for example, in this pipeline, we can get some of the faster activities out of the way in parallel first, like linting and running unit tests. Next, as we run into some of the slower steps, like running integration tests, we can do some of our other slower activities, like building images and setting up the test environment for our end-to-end tests. So tasks and pipelines are types you define once and you use again and again. To actually invoke those, you use pipeline runs and task runs, which are our next new types. So these actually invoke the pipelines and tasks, but to do that, you need runtime information, like what image registry should I use, what Git repo should I be running against, and to do that, you use our fifth and final type, pipeline resources. So altogether, we added 5 CRDs. We have tasks, which are made up of steps. We have pipelines, which are made up of tasks. Then we invoke those using task runs and pipeline runs. And finally, we provide runtime information with pipeline resources. And decoupling this runtime information gives us a lot of power, because suddenly you can take the same pipeline that you use to push to production, and you can safely run it against your pull requests. Or you can shift even further left, and suddenly your contributors can run that same pipeline against their own infrastructure. So this is what the architecture looks like at a very high level. So users interact with Kubernetes to create pipelines and tasks, which are stored in Kubernetes itself. And then when the user wants to run them, the user creates the runs, which are picked up by a controller, which is managed by Kubernetes, and the controller realizes them by creating the appropriate pods and container instances.
Cool, so today I'm excited to welcome engineers from CloudBees and TriggerMesh to talk about how they've been integrating with the Tekton project. And I want to highlight that they were able to do this very quickly because we put a ton of time and effort into onboarding new collaborators. So first I'd like to introduce Andrew Bayer on stage to talk to us about Jenkins X and how Jenkins X is integrating with Tekton.
Hi, I'm Andrew Bayer. I'm an engineer at CloudBees working on pipelines both in Jenkins and Jenkins X. So who here's heard of Jenkins X? That's a lot of people. Who here's played with it or is using it, et cetera? All right, it's good. So in case you're not familiar with Jenkins X, let me try and probably fail to explain it very well and then get corrected. Jenkins X is a new CI/CD experience for Kubernetes. It's designed to run on Kubernetes and target Kubernetes. You can use it for building traditional and cloud-native workloads. You can create new applications or import existing applications into Kubernetes and take advantage of various quick starts and build packs that allow you to get the initial setup of the project, et cetera, without having to do it all by hand. Gives you fully automated CI/CD integrating with GitHub via Prow, so a lot of automation and GitOps promotions, et cetera, without you actually having to go click stuff by hand. It's got promotions, it's got staging, dev and prod environment integration, and a whole lot of other magic. I'm here specifically to talk about the part about how Jenkins X is using Tekton pipeline. So a user is not actually going to necessarily know that they're using Tekton pipelines behind the scenes. We have our own ways of defining your pipelines in Jenkins X, either via a standard build pack or when you define your own pipeline using our YAML syntax. Then at runtime, when a build gets kicked off, Jenkins X translates that pipeline into the CRDs that are necessary to run a Tekton pipeline. And then Jenkins X monitors the pipeline execution, et cetera. So that means that, like I said, the user isn't directly interacting with Tekton. The user's interacting with Jenkins X. That means that we can do a lot of things on our side without having to worry about exactly how the user's going to interact. So why are we using Tekton pipelines? Like I said, I've been working on Jenkins pipelines as well for a while now, and what we've come to learn is that pipeline execution really should be standardized and commoditized. CI/CD tools all over the place have reinvented the wheel many times, and there's no reason for us to keep doing that. So I'm really excited about that. And we really like that we can translate our syntax into what's necessary for the pipelines to actually execute, so that we're still able to provide an opinionated and curated experience for Jenkins X users and pipeline authors without having them to worry about being exactly the right syntax and verbosity, et cetera. And it gets us away from the traditional Jenkins world of a long-running JVM controlling all execution, which is, good. But the best part is, as Kim mentioned, how great it is to contribute and get involved with Tekton pipelines. I only got involved with this at all starting in November, And we've been able to contribute significantly to the project, help with the figuring out direction, fixing bugs, integrating it with Jenkins X, and get this all to the point of being pretty much production ready in just a few months. And that's phenomenal. It's just been a great experience, an incredibly welcoming community, and just been a lot of fun. I don't have an actual demo exactly. Let me go back again. Sorry. Oh, and of course my screen went to sleep. Hold on. Typo. All right, so what I wanted to show you here was just quickly how much of a difference there is between the syntax a user is authoring and what Tecton actually needs to run, and why we think that's valuable. So this is roughly what a obviously brain-dead simple pipeline in Jenkins X would look like. Just, 26 lines. And then when we transform it, well, it's a lot more than that. But because we're able to generate that and not require the user to author it all by hand, we're able to inject Jenkins X's opinions about environment variables, about what images should be used, and a lot more. And it's been really great for us to be able to have the full power of Tecton pipelines behind the scenes during execution without needing to make the user have to worry about all of those details all the time. So that's been really productive for us. So thank you.
So next, I'd like to introduce Chris from TriggerMesh to talk about the work he's been doing.
Oh, cool. Actually, yeah. So thank you, Kim. Thanks, Andrew. Hi, everyone. My name's Chris Baumbauer, developer with TriggerMesh, and also one of the co-authors for TriggerMesh's action. So starting off with TriggerMesh's action, this came out as more of a way of tying in the GitHub actions, the GitHub action workflow once it was announced last October into creating a way of being able to bind that with the Tecton pipeline approach. The idea being that with that workflow, we can translate that into the various resources that the Tecton pipeline now makes available, and then be able to feed that into your Kubernetes cluster and be able to either experiment with it or even create additional hooks so that it can actually receive external stimuli through something like Knative's eventing service. Things such as like whether it is going to be a pull request from something like GitHub, or maybe it is some other web form being filled out that triggers that build or that workflow in the background to provide the result, and ultimately allowing you to run things from anywhere. So a little bit of a mapping exercise for the terminology goes. With GitHub Actions, you have the concept of the workflow. The workflow, it would be like the equivalent of the Tecton pipeline's global pipeline. This is where anything and everything runs task-wise. And then as far as the GitHub action, that is the equivalent of that single step or that task where it's going to be that one container that runs that command that produces the output. And I do call out one of the other components within the GitHub action, which is called uses. This is more of being able to define the image that you want to run within your Tecton pipeline task. Whereas with the Tecton pipeline tasks, expect a particular image. What we end up translating with the GitHub actions, or at least we will once I finish my pull request, is that we'll be able to allow the full support that GitHub has for their actions, as far as being able to point it to another GitHub repo or point it to some other local directory within that repo that you have defined, to be able to build the Docker image that you can then feed into the task to work the magic, as it were. So as far as our little pretty picture, with the trigger mesh action, we actually have 2 commands that handle everything. We have down at the bottom the create. This one creates the tasks, creates the associated pipeline resources, and you can also use it to create the task run or the pipeline run object to create like a one-shot invocation. Usually if you want to test something out to see if you've got your workflow working just right, or if you wanted something else to call into this. And up above is we also create a Knative eventing sync, as well as the associated transceiver, which creates a serverless service within Knative to handle the creation and the invocation of that task run object. So to give you a little bit of a quick demo of what we have, let's see if I can, oh, perfect. So what we're looking at right now is the customary hello world example. You'll note up at the top we do have our workflow defined, this one being more of our pipeline object. The resolves indicates all of the actions that would be associated with our workflow, and the on usually indicates the type of action that would happen within your repo. And then right below that one for the action, you'll have some kind of identifier are naming it, the fact that we're using CentOS as our base image, and of course we're just going to run hello with our specification for the environment variable. We do also see that args does allow you to pass in either a string or an array of strings to go in as well, which is one of the nice things about their language. And as far as like some of our translation, we take care of that for you. So with the action command itself, as mentioned beforehand, you have your create, you have your launch. One of the things that we originally had started working on is our own implementation of the parser for the GitHub action workflow syntax. But since GitHub was kind enough to open source it back in February so that experimental projects such as these can make use of it, we've started transitioning to that one. So now it acts as more of a sanity check on whatever workflows that you feed in to ensure that it does what it's supposed to do. As far as the common global arguments, we do allow for passing in your Git repository. When it comes to creating things such as the collection of tasks with the create command, it is used for being able to not only create a pipeline resource that could be referenced by additional steps in case you wanted to add things to it, but also in the case of specifying like that local directory so that we know which repo to pull the Docker from to build the image. So now, okay. We'll feed that into our hello world. We just feed everything as is, and we have our simple task object. You'll see our steps have actually been broken down. We have our simple command, we have our environment variables, we have our new and improved image, and we also have our name, which has been Kubernetes-ified to resemble their traditional naming scheme. And then we can pass in -t to provide our task run object. And then, give our favorite apply F. Hopefully it'll still talk to my Kubernetes cluster. And we have our objects that are created. And it looks like it just finished. So we have our true, we have our success, and we also have a pod name, so we can go here and take a look at any output in the case of failures, or if there was something that you wanted to grab as part of any of the successful messages, and some or other things along those lines. And then, if we were to look at launch, the one thing it does require is that we do pass in a task. Let's see if I can. Come on. This one does also require that you specify a GitHub repo. All right. And this one, so here we have our eventing the source definition, specifying going into GitHub, the request for pulling in our credentials, and also the task that it'll create and fire. So that, I believe, is pretty much it.
Awesome. So thank you, Andrew and Chris, again, for sharing your work with us. Like I said before, we're not doing this alone. And Tecton is actually part of a new foundation called the Continuous Delivery Foundation. This is an open foundation where we're collaborating with industry leaders on best practices and guidelines for the next generation of CI/CD systems. And so initial projects of the CDF include Tekton, Jenkins, Spinnaker, and Jenkins X. Now you've seen Tekton integration with Jenkins X. We're also excited that we're starting to integrate with Spinnaker as well. And so these are the current members of the CDF, and we're really excited to work with them on our mission to help companies practice continuous delivery and bring value to their customers as fast and securely as possible. So if you want to learn more about the CDF, please check out cd.foundation to get involved or just kind of watch what's going on.
All right, so what's coming next? So for the CDF, we have a co-located summit coming up in KubeCon Barcelona on May 20th. And if you're interested in what's coming down the pipeline for Tekton pipelines, we're currently working on some exciting features like conditional execution and event triggering and more. And for Tekton itself, we're looking forward to expanding the scope and adding more projects. And we recently had a dashboard project added. And so for takeaways, if you're interested in contributing to Tekton or you're interested in integrating with Tekton, please check out our contributing guide in our GitHub repo. It has information about how to get started developing and also how you can join our Slack channel and our working group meetings, etc. If you're an end user, check out Jenkins X, check out Trigger Mesh Action, and watch this space for more exciting Tekton integrations in the future. And that's it. Thanks so much for listening to our talk.
Yes.